Everybody. This is the first video for both my geometry and my STEM geometry class. Just section 1.1 in the book, segment, length, and midpoints. I realize some of you may not have the book yet. Just follow along as best you can, and don't worry about taking notes. I usually don't grade those anyway. So this first section is actually going to be all about definitions. So we have to cover a handful of these definitions, and a lot of these things we're not going to prove or give evidence for. We're just going to define what they are and move on with our life. So first up, it's a point. So a point is a specific location in space. We represent it with a dot, and then we give it a name. Oftentimes these names are letters. So we'd say this is point P right here. Note the dot, a point isn't just a tiny circle, right? There's no width to a point. A point actually has 0 dimension. It doesn't have width, it doesn't have height, it doesn't have depth. There's 0 dimensions to a point. If I were to zoom in on a point, that point wouldn't move. It would just be the same size, a tiny little infinitesimal thing. Another one is a line. So in geometry, this whole class, whenever we say line, we're going to say that means it's straight. At no time will we have a line that goes in a curved manner. We're going to call those curves or arcs or something else. So a line goes in 2 directions. It goes front and back. It goes to infinity both directions. So it goes on forever. And we represent that infinity with these arrows. So we have point A and point B here. And the line goes through point A and B in this direction and this direction. And it goes to infinity. We represent it with the little arrows here. And there's a couple different ways we could name it. We could name it using the points that it goes through. So we have line AB here, or line BA or something like that. Or sometimes we give it a separate letter. That's fine as well. When we draw it or write it out just as text, we can write AB, and then we draw this little line symbol over the top. See how it has 2 arrows? That just represents that it's a line that goes on forever. And then finally a plane. So this here has 0 dimensions, right? This here has 1 dimension, right? It has actually 0 dimensions as well. It has length, but it's infinite length. Planes have 2 dimensions. So they're a flat surface, right? Think of something that's 2-dimensional. So a sheet of paper is, 2-dimensional. Again, we're not going to introduce curves and make it all weird here. You can just imagine a plane as a sheet of paper that goes infinitely in all directions. Okay. Next up is a segment. Now, a segment's similar to a line, except for the fact it doesn't go forever. So it simply goes between 2 points. It is the portion of the line, line CD, that's between point C and point D. So we would call this segment CD. When we draw it, we can write DC or CD. Order doesn't matter. But we're going to put a little segment symbol over the top. So it's just going to be just the line without the arrows, right? And then finally a ray. Rays go in one direction, but they go forever in that direction. So if we have ray PQ here, the first letter represents the starting point or the origin, and then it goes through Q, and then it just keeps on going, right? So it goes on forever once it goes past Q. And for this one, order does matter. We call it ray PQ, or we can draw it like this with a ray symbol. So it's a ray is kind of halfway in between a segment and a line, in that at one end it's bound, right? So you don't put any little arrow representing infinity. At the other end you do put a little arrow. So those are the tools we're going to work with for this first unit. We also have the segment addition postulate. A postulate is something that we're not going to prove. So we're just going to take this as fact. And the reason why we're going to do that is because it's pretty difficult to prove some of these things. They're just so basic and so fundamental to the rest of our work that we're just going to say, oh, yep, it's true, and then move on with our life. So for example, this postulate just says if I have A, B, and C all in the same line, AB plus BC equals AC. And a lot of you guys will just say, oh yeah, duh, if this is 4 and this is 2, then the distance from A to C is 6. but we are going to state it here so we can use it in some of our logical things later on. Okay, let's talk about this thing. Should be familiar. This is the Pythagorean theorem, right? So if I know two of the sides of a right triangle, you should be able to figure out the third. Often is the case, you'll know the two legs, you can figure out the hypotenuse, but you should be able to do it either way. And the reason why we need this Pythagorean theorem is because you're going to be doing this formula over and over again. If you haven't covered this in algebra class, that's okay. We'll get through it here now. But the distance formula is simply finding the distance between 2 points in the coordinate plane. And you can think of that distance here as the hypotenuse of a right triangle, right? You see the right triangle? So we have this formula. This is a fancy version of the Pythagorean theorem. X2 minus x1 is simply this length here. So let's call that A. Y2 minus y1 is this length here. Oh, sorry, other way around, doesn't matter. I'll call that B. So it'd be A squared plus B squared equals C squared. But then to calculate for C, you have to take the square root. So it's the square root of A squared plus B squared. Gives you length C. So you can use either one when you're doing these problems. I'll show you how to do both. In fact, we'll just skip this here. Okay. So I can do this. Okay, so this one here, I'm going to skip to part B. It asks you to determine whether the segments have the same length. So what's the length of EF and GH? Well, EF and GH. To use the distance formula, you have to figure out the coordinates of E. So that's at -3, 2. Coordinates for F, -2, -3. You plug those into the formula. Similar to G and H, you find H, which is at 2, 0. And then you plug all those numbers into the formula for EF. -2 minus -3 is 1, right? -3 minus 2 is -5. 1 squared plus -5 squared, that's 1, that's 25. 1 plus 25 is 26. So the square root of 26, same deal, we can do that with the rest. And we get square root of 32. So therefore, they're not the same length. I find the distance formula a little harder because there's so many things that go wrong. If you're not careful and you get one of these 4 points, you have 4 points, you have 2 coordinates for each point. So that means that there's 8 numbers floating around. If any one of those are wrong, you're just up a creek without a paddle. You're going to get the wrong answer. Hopefully you can catch your mistake, but you might not. I find it's a little easier just to think about these as the Pythagorean theorem. So I think, oh, there's going to be a right triangle where the hypotenuse is that length that I want to find. And then I can simply count. If it's in front of me, I can just count it. And I say, oh, what is A, right? What is B? And then I'm going to calculate C. So A in this case is 1, 2, 3, 4, 5, 6. So that's 6 squared plus 1, 2, 3, 4, 5 squared, and then I take the square root, right? So it's 36 plus 25, or the square root of 61. So either one is totally valid. It's up to you. Okay. For this one here, I'm going to let you do this one on your own. Just kind of check your work. Use one of those methods, and then I'll go ahead and reveal this work here. So pause the video if you want to practice. Okay, so the correct answer is that they're both square root of 13. We can just leave it as that answer. Decimals aren't necessary. So hopefully you got them both to be the same length. Okay, final little thing is to find the midpoint. So a midpoint is when you're between two things. So here's point P, here's point Q. We know M is the midpoint because of these marks. We have this mark here and this mark here. These are called congruence marks. We'll cover these more later, but for right now, just realize that that means that PM is the exact same length as MQ. So therefore, if PM is the same length as MQ, we know that M is the midpoint. When we're given figures, we can actually also make a few assumptions as well. One assumption we can make on a figure is if it looks like a straight line, it is a straight line. So does PQ look like it's a straight collinear? PM and Q, do they look collinear? Well, yeah, they do. So we can assume that it is collinear. We don't have to second guess ourselves and be like, oh, maybe there's a tiny little angle change in here. No, we don't. We can just work with what's depicted. In this case, M is in the smack in the middle of P and Q, using those tick marks. So line L, therefore, would be bisecting it, right? If I have two kids arguing over a piece of cake, I'm going to bisect the cake so they each get half. And that's what line L has done with segment PQ, bisected it in half. This leads us to our midpoint formula. This one is probably new, although it's pretty simple. It looks big and complicated right now. I promise you it's not. What they're doing here is they have point A and they have point B. So point A is found at this x coordinate, this y coordinate. Point B is this x, this y. The midpoint is going to be directly in between. If I asked you what number was in between, say, 2 and 4, you would tell me 3, right? You just know that automatically. Well, you can also mathematically get 3 as between 2 and 4 by averaging them, right? So if I do 2 plus 4, divide that by the number of items I had, that'll give me 3. Same deal with, like, say 8 and 10. What's in between 8 and 10? Well, the average of 8 and 10 is 9. So you're going to do the same thing here with point M. You're just going to make point M the average of points A and points B. So that's what this part of the formula is. X1 plus X2 divided by 2, that's the average of the two X's. And that becomes your new X coordinate for point M. Y1 plus Y2 over 2, that's the average of the Y's. And that becomes your Y coordinate for point M. We'll do one example here. I'll do 11 and then I'll show you the answer to 12. So you'll want to pause it. Heck, you can try both if you want. For this one here, we just need to calculate the midpoint of AB, essentially. So what is the average of 6 and negative 6? I'm going to write it out, even though most of you can do this. 6 plus negative 6 is 6 minus 6 over 2 equals 0. So that's my X coordinate. Then I'll do the average of negative 3 and 3. Negative 3 plus 3 divided by 2 equals, in this case again, it's 0. So my final answer should be 0, 0. And we find out that it's the origin. Yay, we did that one right. Okay, pause here and try number 12 if you can. If you did it right, you should have got the coordinates of 1, negative 2, and that's in quadrant 4. Don't worry, we're not going to really need to know the quadrants. You should know them. You've just taken algebra, but it won't be it'll come up in a few problems, but it's not critical to know. Okay, that's it. That's all I got. Sorry, I ran a little over 10 minutes. Have a good one.